Alright, welcome to our video. Today we're going to solve one exercise from the topic Newton's second law of motion, concept of a system. Remember that all of these exercises are from the book College Physics. And this exercise is problem 11, and it says the rocket sled shown in figure 4.33 accelerates at a rate of 49 meters per squared second. Its passenger has a mass of 75 kilograms. Part A. Calculate the horizontal component of the force the seat exerts against his body. Compare this with his weight by using a ratio. Okay, the first thing we're going to calculate is that force, the horizontal component of the force the seat exerts against his body. Okay, first of all, I would like to draw that chair so you can see it. Alright, it won't be that perfect, but here it will be that chair where this pilot is sitting, a passenger of this rocket sled, and the chair is. Now what we're trying to calculate, what we have to calculate is this horizontal force the seat has to exert against his body. Why is it that? Okay, first of all, this rocket sled is accelerating to that direction, so the seat must hold that acceleration. When the rocket sled starts to accelerate, the whole body of that passenger is pushing against the back of that seat, so the seat must exert some force so it won't fall down. So what we're going to calculate is that force, the force of the seat. We're going to call it Fs, force of the seat. Okay, and here we have this Newton's second law of motion. It states that the addition of all the forces is equal to the mass times the acceleration. This time we only have one force involved, that is the force of the seat. The force that the seat is exerting against the body of the pilot equals to the mass times the acceleration. Okay, we don't have the force of the seat, but we do have the mass, which is equal to 75 kilograms. That's the mass of the passenger times the acceleration. And if the rocket sled is moving with an acceleration of 49 meters per second per square seconds, that is also the acceleration of the passenger who is inside that rocket sled, 49 meters per squared seconds. And once we multiply that, the answer for that, it will be 3,675 newtons. Don't forget that kilograms times meters per square second is equal to newtons. That's the force that the seat is exerting against the body of the passenger. Now, same part 8 says compare this with his weight by using a ratio. So for that, we have to calculate the weight of that passenger. And that's very easy. The formula of the weight is mass times gravity. The weight of the passenger, it will be equal to the 75 kilograms, which is the mass of the passenger, 75 kilograms, times the value of the gravity, which is equal to 9.8 meters per squared seconds. Okay. And the answer for that, it will be 735 newtons. Now we have to compare this weight with the force that this passenger is feeling in his back. So how can we do this? Well, here they say that we have to use a ratio, and for that we have to make a rule of 3 or a direct proportional rule. That is, if one planet Earth, or our planet Earth, is able to produce a force of 735 newtons on his body, remember that the weight is the force which gravity with which the gravity pulls us downward. So if one planet Earth is able to produce this force in the body of the passenger, how many planets Earth are needed to produce the force that the passenger is feeling in his back, on his back? 30,675 newtons. Alright, so for that we must multiply 3,675 newtons by one planet Earth, and all of that must be divided by 775 newtons. Alright, so here we can cancel the newtons. What will remain is planet Earth. So 3,675 multiplied by 1 is going to be the same, but that divided by 735 is going to be 5 planet Earth. Alright, so 5 planet Earth would exert that force on his back. In physics, it's more suitable to talk about 1g, but capital G, to make a difference with the value of the acceleration due to gravity. 1g is able to produce 735 newton on the body of the passenger. So 5g are able to produce the force that this passenger is feeling on his back. 5g. That's how we say it in physics. Now we have answered part A. Remember, the first thing what we did was calculating the force that the seat is exerting on his back, on the passenger's back, with the Newton's second law of motion. Then we calculated the weight to know the force, or the G forces that would produce this force on his back. Now we had to do something different in part B, because in part B we had to calculate the direction and magnitude of the total force the seat exerts against his body. Okay, there are two forces acting on his body. In part A we saw that we have the force of the back of the chair. We calculated the force of the back of the chair, which was equal to 3,675 newtons. And we're going to draw an arrow to give a better sight of that force. There it is, the force of the seat. But there is other force acting on the body of the passenger, and that is the normal force. Remember that the normal force is the force that every surface exerts against a body that is on it. In this case we have the passenger, which is sit on that chair, so the normal force is acting on him. That's why sometimes we feel our butt a little bit tired after we have been sitting a while on a chair. All right, so that's the normal force acting on us. And the normal force in this case is also acting on this passenger. This is a normal force. Okay, so we have the force of the seat, but we don't have the normal force. And here we have the formula of the normal force, which is quite alike to the formula of the weight, mass times the gravity. So quickly we can say that the normal force is equal to 735 newtons. Easy peasy. There we have it. And as you can see here, the two forces are perpendicular to each other. We have the force of the seat or the back of the seat. This time I'm gonna call it BS, force of the back of the seat. And I also have the normal force, which is the force of the bottom of the chair. The bottom, well, I don't know. Two forces are perpendicular to each other, and to calculate the magnitude of the total force, we have to use this formula. So here we go. The total force is equal to the square root of the horizontal forces squared, where the horizontal force is going to be the force of the back of the seat. This is the only horizontal force that we have, and that horizontal force is equal to 3,675 newtons. Squared plus the vertical forces, well, the only vertical force that we have here is the normal force, and that is equal to 735 newtons. Squared. Now we have to solve this in order to get the magnitude of the total force. So once we rise to the square and add up that, we will have the square root of 14 million. $45,000 850 squared newtons. And the square root of all of that is going to be 3,747.78 newtons. Don't forget that we can cancel here the squared with the square root. So that's the magnitude of the total force, which, by the way, will go to some place over here, okay? And to know exactly where is going to be that total force, the direction, we need to calculate an angle by the inverse of a tangent. There we have the formula. And we have to calculate the inverse of the tangent of the division of the vertical force, which is 3,000, 745 newtons. Newtons, and the horizontal force, which is equal to 3,675 newtons. Well, the division of that is 0.2. The inverse of the tangent of 0.2, sorry. And the inverse of the tangent of 0.2 is equal to 11.31 degrees. And that's the angle of the total force. And with that, we have finished the exercise. Okay, don't forget that in part B, they're asking us about the direction and the magnitude of the total force the seat exerts against his body. In part A, we calculated the force that the back of the seat exerts against the body of the passenger, but we didn't calculate the force that the top of the seat, the bottom of the seat exerts against his body, and that is nothing more and nothing less than the normal force. Normal force has a formula which is very alike. In fact, it's the same formula of the weight, mass times gravity. We calculated that in part A, so the normal force is equal to 735 newtons. After we did that, in order to calculate the total force of two perpendicular forces to each other, we have to use this formula. The horizontal force was the force of the back of the seat, and the vertical force was the normal force. We used the formula and we calculated the total force. And finally, to calculate the direction, we have to use the inverse of the tangent of the vertical forces divided by the horizontal forces. You have them all. We have all of them. The vertical forces and the horizontal forces, we just divide and calculated the inverse of the tangent. That's it. That's all we have to do. And with that, we have finished the exercise. I hope you could understand it, and I'll see you in the next video where I'm going to work with some other exercises about the Newton's second law of motion. Don't forget to give me a thumbs up, and goodbye.